A charged particle moves in a magnetic field B of 10 I cap with initial velocity 5 I cap plus 4 J cap. So magnetic field here is given to be 10 I cap and initial velocity is 5 I cap plus 4 J cap. The path of the particle will be. So here you can see that magnetic field is purely along the x-axis. That means say magnetic field is this way. Suppose magnetic field we are assuming in this direction. That means we are assuming it to be x-axis. And suppose here is our y-axis. Velocity has got both components positive. That means velocity vector must be directed somewhere like that at certain angle theta with this magnetic field. Okay. So this velocity vector will be at an angle theta with this magnetic field, and theta can be calculated with the information given here because both the components are known. So tan theta is anyway 4 by 5, but that's not required. So we have to find the path of the particle. As we know that this velocity has got two components. One component is parallel to the magnetic field and the other one is perpendicular to the magnetic field. So these two components, one is parallel to the field and one is perpendicular to the field. Parallel component of velocity is not affected by the magnetic field, as we know that magnetic force is F is Q V cross B. That means if velocity is parallel to the magnetic field, then no force will act. So parallel component is not going to get affected by the magnetic force, and the component which is perpendicular to the velocity, perpendicular to the magnetic field, that will force this particle to move in a circular path. But this V parallel will move the particle forward. So the resultant path of the particle will be like that. It will be moving in a circular path and as well as advancing in the direction of the magnetic field because of this V parallel. So path of the particle is going to be helical. And whenever there are certain things which may be asked, like pitch of the helix. So pitch of the helix can be calculated by time period. What is time period of circular motion? That is 2 pi m upon qb into the parallel component. So what would be the radius of this circle? If suppose you are asked for the radius r, then radius is n v perpendicular divided by qb. You know these formulae. Okay. So C is the correct option.